Hello, Hello everyone. My name is Namuga Matha, and my project is an AI model for sorting seeds. So my presentation is going to flow as follows. I am going to have a problem being investigated, the background, the accountability, the significance, the scope, the problem statement, the research questions, the hypothesis, the research objectives, the data set description, the methodology, and a few references. So what problem is being investigated? I looked at the difficulty in sorting seeds meant for consumption or exportation. So in this particular time, I looked at coffee seeds. We do know coffee contributes about 30% to our GDP. So we need to sort these seeds for not only us, the consumers within the country, but also those that for which the countries to which we export. So how is having unsorted seeds a problem? We know that coffee is roasted, but we also know us as consumers, we have different preferences. We'll have those who prefer overly roasted coffee, those that will not want coffee that's roasted at all. So we do have those different preferences. So how are you going to achieve my demand if you're not sorting the coffee that I need? So that's why we need to sort these seeds. Then we'll look at the background. As we said, coffee, and we know that coffee is among the commonly grown cash crops, and its exportation contributes 30% to our GDP. So if we're looking at this fact that it has a big that way on our economy, we'll have if we sorting this coffee will give us an added advantage in the world market. How we are a step above, we'll have being able to sort these seeds to meet the demands of other people. And it will not only have an advantage to our economy in such a way of exportation, but also us within the country. People are going to, the demand for this coffee is going to increase because you've sorted it to people's liking and to their demand and to their choice. They will have a choice of choosing what they need. So that's the background of this project. Accountability. Is this AI held accountable? So let's start with the performance. Is the model we're building performing the way it's supposed to perform? Is it able to tell the difference between an overly roasted seed, a mildly roasted seed, or a seed that's not roasted at all? So is it performing to its expectations? If not, who's held accountable? That's the governance. Who's held accountable for in case of failure? If the model is not able to, is it the developer, is it the person currently owning it, or the government? My opinion is the developer, because you're the one in charge of your model. You've built it, so you're supposed to know the reason as to why it's not performing the way it's meant to perform. And then we have the data. Which data is your model dealing with? Our model is dealing with images of the different roasted seeds. So it's supposed to look at those images and process and be able to differentiate between a dark seed which is overly roasted, or a green seed that's not roasted at all. And then the monitoring. Who monitors this model? This model is monitored by the people that are currently using it. If it's not able to perform to its expectations, they will report the case to higher authorities. So the significance, the importance of my project, is it's important in such a way that it eases the packaging process. How does it ease the packaging process? After sorting these seeds properly, they can be easily packaged and exported or distributed to the different places, and it's going to give the consumers choice to choose what they want. So I'm not supposed, I won't get seeds that are not sorted at all, because if I don't want them, I'll get those that are overly roasted or those that are not roasted. So I have that choice to make. So so we'll prevent wastage, and there will be value for money. Then we have the scope. How we identify the problem. The problem is we have unsorted seeds, and yet us as consumers, we need something that's sorted. So we look at the solutions available. One, we either stay with the seeds that are not sorted and we'll deal with the consequences of like reduced demand, or we manually sort these seeds, or we build a model that can sort them for us. Now, the first suggestion is us not sorting. Why would we settle for something if we have other options? I don't think it's the best solution. So we go to the next of manually sorting your seeds. Yes, we can manually sort the seeds, but it will take a very long time. So we look at the next option. Next option is building a model that's going to do it for us and in the shortest time possible. So we'll opt for building a model that is going to do it in the shortest time possible. So we can also set milestones. These milestones are like the goals that are meant to be achieved at a particular point during our entire process of building this model. We will set our milestone to at this point in time, we're supposed to have finished training that model with the data we have. After that, at this time, must be able to test, and this model should be able to tell the difference between all the seeds. So those are the milestones, that they are the simple goals that are meant to be reached at a particular point in time. Then we'll have the evaluation matrix. What are we going to use to evaluate our model? Is it accurate? So we'll use the accuracy, precision, F1 score, and recall to evaluate our model. Then the resources. Are the resources available? What are the resources needed for your project? We'll need a computer, a camera for high resolution, because we're mainly dealing with images. So that's something that cannot miss. And then also need the hardware, where we put the seeds and all that, and then we also need the seeds themselves, which will be readily available. This project is more of a commercial project, so most of these things will need something big, so it tends to be expensive. And then we have a problem statement. We want to increase the income from coffee seeds by sorting them according to the degree to which they've been roasted. So our problem, as we stated, is an uncertainty. Which people does it affect? It affects the consumers and the people in the exporting companies. So these exporting companies need to sort seeds, but how fast can they sort them? So we need that model that will help us sort them. Even as the consumers, we need something that's already sorted, because we have different demands. So it affects us as well. So that's a problem statement. So we need to solve that problem. So this model comes in to solve the problem for both the consumers and the exporting companies. So research question. So these are questions you look at when you're coming up with this model. What is it solving? Is it useful to the community? How feasible is this model that you're building? Is it optimal? Is it financial? Can you afford it? And is it environmentally friendly? What challenges does it have? Are the resources available for the model? All these are questions that are asked before we proceed with building this model. Then we have the hypothesis. This is what will happen if we actually deploy this model. So we need this model will be able to solve a problem by identifying the seeds and sorting them according to their color, which color is representing the attribute of roast, the degree to which have been roasted, and then it also solves problem bias. And then we have the research objectives. This is what our model is aiming to achieve. So we want our model to be able to sort these seeds. Not only should it be able to, but it should sort them correctly and in the shortest time possible, and using minimal resources. So that's what our model should do. And it should have the highest productivity, because we can't opt for that model yet we can do it. So this model should have a higher productivity. Data set description. The data set that is picked for this project is the coffee bean data set, and it has 4,800 images on which they are categorized and they are labeled. So these are the features of this data set. The data set has labeled data. It has an index, and indices of 0 and 1, and a file path. How important are these features? So it's going to help us categorize the data. we'll know this one is for training the model, this one is for testing the model. So we'll know how to use that. Then the label helps us to categorize the seeds. We have the dark seeds, the brown seeds, the green seeds. So this is how important the labels are. And how did we come up with this data set? These images were captured using a high resolution camera and they were categorized. So that's how we came up with that data set. So the methodology, this is like a research approach. So we have these processes: the data collection, pre-processing, training, testing, evaluation, and explainable AI. So in data collection, as you have said, we collected the data using images. We took images of these different seeds and that made up our data set. So what did we do on this data after capturing? We gave it categories and labeled it, and also separated it into training and testing. So went in for model training. Model training, the model is trained using these images that we have captured. And after it's trained, it's tested to see if it has actually learned. Can it tell the difference between a dark seed, a brown seed, and a green seed? After testing it, we evaluate it. Is it accurate? Has it properly distinguished between the different kinds of seeds? So we use accuracy, precision, F1 score, and recall. Then the explainable AI, we use SHAP, which stands for Shapley Additive Explanations. We are going to look at the different factors. Yeah, it's a technique. We're going to add up the different factors and come up with a prediction. Yes, once we look at these different factors, we join them and we can be able to predict an outcome. So that's the AI technique. Then we'll have a few references: the Uganda coffee, the data set, and my Kaggle account. Thank you so much and have a lovely day.